Hello friend, welcome to Plastic Product Design series. So in this video we will discuss the most common manufacturing process that are used to get the plastic product. So there are a number of manufacturing process are available in the industry to get the plastic product, but these are the common and the most used manufacturing process to get the plastic product, like injection molding, blow molding, extrusion, rotational molding, or we can say the roto molding, thermoforming, compression molding, and the 3D printing, or we can say additive manufacturing. So we'll discuss briefly in this video, and in upcoming videos I will upload the separate videos so that we can understand in detail, but in this video I will just highlight the few points only, and in upcoming videos we will see in the detail. So let's start with the injection molding. So this process actually it is mostly used to get the manufacture to get the plastic product. So like in the toys, automotive part, consumer electronics, and medical devices. And from the injection molding we get we can produce the complex part, and this injection molding having the high production rate, excellent repeatability. So you can see the injection molding, the cost of the injection molding machine is very high, and this and the injection molding machines is also in big size. So it contains the clamping unit, mold unit, and the injection unit. Okay, so this is the complete injection molding machine. Generally we call it as a IMM. Okay, so the feeding of the material into the mold is generally is based on the injection type process. So like we are forcing the material into the mold. So it is the principle, it is based on the injection. Okay, so the disadvantage if you see, so it is having high initial mold cost and limited to part with the consistent cross section. Next one is the extrusion. So the extrusion process we generally use to get the uniform uniform cross section throughout the length. Like you can see this. Suppose I want this cross section completely. So like that, the tubing or the cross sections like a rectangle, circular, triangle, this type of shape. So if you want the continuous throughout the length, so at that time we use the extrusion process. And this extrusion process we have discussed. So this extrusion process is used for palleting also. So like in the pipes, tube, profile, film, sheets. So these are the application of the extrusion process, and the advantage is like a continuous production, low tooling cost, and ability to produce the long part with the uniform cross section. Okay, and the disadvantage is limited to the part with a consistent cross section. So suppose we have the complex geometry, so at that time we can't use the extrusion process. So for that we may go for the injection molding, and here it is a lower dimensional accuracy compared to the injection molding. Next one we have the blow molding. So in the blow molding we the main important process is the parison. So this parison is injected mold where we are blowing the air. So first the mold is open, then we need to close this mold after injecting the parison. So the parison is sticked here, and we need to blow the air inside the parison so that the parison get the complete shape of the mold, and then open the mold and eject the part after the cooling. Okay, so this blow molding is used to create the hollow part, and like in the bottle, containers, automobile fuel tanks, and the toy. So it is suitable for the hollow part with the high production rate for the container. Okay, and the disadvantage like limited to hollow shape and the material waste during the trimming. So you can see the bottom side and the upside, so we need to trim the material. So it is a wastage of material for each part or the each product. And then we have the rotational molding. So this process is also used for the hollow part, but for the big size component, and the production rate is compared to the blow molding, the production rate is slow here. So here we use this complete big mold, and in that we are placing the material and rotating this complete axis throughout the process. So this process contain the feeding of the material, heating of the material, and this so this axis is continuously rotating, this mold is continuously rotating. So it goes after the feeding of the material into the mold, it goes to the heating chamber, then it goes to the cooling chamber, and then we are, after the cooling, we are ejecting the part. So this material during the rotating of the axis, so this material stick to the wall of the mold, and it forms the uniform wall thickness. So here the large hollow objects like a tank, kayak, playground equipments, so for that purpose we use the rotational molding. So in the separate video also we'll discuss the rotational molding in detail. And the advantage, like it produces the very large part, hollow part, and with the uniform wall thickness and low tooling cost. Okay, and the disadvantage, like longer cycle time, so it takes the uh, 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 long cycle time, or takes the time for producing the part. And in the blow molding, it is fast cycle time. So means the production rate is fast in the blow molding, but in the here rotational molding, the production rate is slow. So here limited to the material option and the lower surface finish quality. These are the disadvantage of the rotational molding. Then we have the thermoforming. So in the thermoforming, you can see this is a hard tool, or you can see this is the one side mold where it is a stationary, and bottom side there is are the air vent like this, and we are the millable sheet plastic sheet. So it is a heated, small heated, so it is completely means sticked with the mold. So it is open now. We are moving this plastic sheet on the this mold, and it will form the shape of the mold on the one side. So this is the thermoforming process. So the plastic sheet is heated until the pliable, and then form over the mold using the vacuum pressure and the mechanical force. So these sheets we are forcing or placing over the mold, and it will takes the shape, because this sheet is plastic sheet is pliable, and it can form over the shape. Okay, so the form part is cooled and trimmed to the final shape. So these extra portions we need to trim it. So the application, like a packaging, tray, automotive panel, and these are the application of the thermoforming products. And the advantage, like low tooling cost, suitable for a large part, and then quick prototyping here possible. And the limitations are, it is limited to thin wall part, and the material are waste during this process, so we need to trim it. And here we have the lower precision. Then we have the compression molding. So in this process you can see, so we are placing the material, generally we call it as a charge, and here the lower fixed mold, and the upper is the movable mold. So we are fixing here and compressing this material with the help of this movable mold, and we are getting the shape here. So this is the compression molding. So the measured amount of plastic materials we are placing, and in the heated cavity of the mold. So here this fixed mold, it is in heated, means we are heating these charge or the material in this mold itself. So the mold is closed, and the pressure is applied to form the part, and the part is cured under the heat and pressure, and then we are ejecting this part. So the compression molding applications, like in the electrical component, automotive parts, and the kitchen wares. And if you see the advantage, it is suitable for the high strength, high density part, good surface finish, and the low material waste. And the disadvantage like a longer cycle time, limited to simpler shape, and the higher labor cost. So next one we have the 3D printing. So generally we call it as a additive manufacturing also. So the layer by layer it forms the part. So step by step or the layer by layer it will add the material and it will form the part. So this process is generally used for the prototyping. Suppose you are designing any product and you want to test the product or you want the prototype of that product, so at that time so the 3D printing is very useful. So for the prototype purpose we use the 3D printing, and some small parts also we use the 3D printing. So there are the different types here. You can see the fuse deposition modeling, stereolithography, selective laser sintering. So these are the types. And the digital model is sliced into the layers which then subsequently deposited or cured to form the final products. That I already said, that it forms the part by layer or by the addition of a small material. Like so the application like in the prototype, custom parts, or the low volume production or the complex geometry, at that times we use the 3D printing. And the advantage like here, the no need of any mold. Okay, so directly we are scanning the part, means require CAD file, and we are getting the part. So here the high design flexibility is there, rapid prototyping is there, and the ability to produce the complex shape. So these are the advantage of the 3D printing. And the disadvantage like slower the production rate, limited material choice, and the layer line can affect the surface finish and the strain. Because in this 3D printing process, so the layer by layer we are adding the material. So for that purpose some layer lines you can physically, means while feeling that product. So if you see the physical product, so at that time you can see the layer or the lines on the product surface. So this is a short description or the short explanation on the plastic manufacturing process. But in upcoming videos, in the next section, so we'll discuss the in detail each process, like on the injection molding, blow molding, rotational molding, and all other process. So we will discuss the dedicated videos we will upload on the particular plastic manufacturing process. Okay, so I hope you get a few ideas from this video, or short you'll understood this short explanation. So stay connected and watch this complete series. So thank you for watching. See you in the next video.